Hello, and welcome to Science for Sleep, where the wonders of the universe drift gently into your dreams. Tonight, we begin a quiet journey, not through galaxies or black holes, but through a single sheet of paper, a letter, written by a man at a wooden desk, in quiet ink, on an ordinary day. A letter that did not shout, did not arrive with thunder or ceremony, but it changed the course of science forever. Inside this letter was an idea so bold it bent time, unfolded the energy inside matter, and whispered to the stars themselves. And it all began with one quiet moment of thought. So settle in, let your breath slow, let your thoughts float, and let's follow this letter. From the fingertips of a quiet genius to the very fabric of the universe, this is the story of how one letter rewrote the laws of reality. Let's begin. It begins with paper, smooth, off-white, faintly fibrous beneath your fingertips. It waits on a desk, quiet and patient, like a breath held in a still room. You imagine the gentle scratch of a fountain pen, ink, dark as midnight, flowing slowly from thought to page. The letter itself is unassuming. No gold seal, no thunderclap, no whisper from the stars. Just a folded sheet, slipped into an envelope, carried by hand or post. But inside, something moves. An idea, subtle, but unstoppable. You can almost hear it. The rustle of paper in a study filled with soft lamplight. The faint ticking of a clock. The silence of a mind gathering the universe into words. It is 1905. A man sits at a plain desk in Bern, Switzerland. He is not famous. Not yet. He has no laboratory, no title, no team. He works as a patent clerk, reviewing other people's inventions. But this letter is his. His name is Albert Einstein. He is 26 years old. And in this year, this one astonishing, ordinary year, he will write not one, but four letters that change the fabric of physics. This chapter begins with the first. The envelope is addressed to Annalender Physik, a German scientific journal where new ideas arrive not with fanfare, but with patience. The letter is titled, On the Electrodynamics of Moving Bodies. A title so plain, it barely stirs the air. But what it holds inside is a quiet revolution. You pause. Let yourself breathe. Feel the paper in your hands, imagine though it may be. This isn't a fantasy. This letter exists, and you are now its quiet reader, as if time folded gently to let you in. It speaks of things that seem invisible. Motion, light, space, time. Not things you can hold, but things that hold you. Things you live within. Like air, like gravity, like now. You trace the opening lines. They're calm, deliberate. No grand declarations. No fireworks. Just a question posed softly. What if the laws of physics are the same for everyone, no matter how fast they move? What if time, which feels so steady, is not the same for all? Imagine riding a train. Outside, lightning strikes on both ends of the track. You, inside, see them at different times. But someone watching from the platform might see them as simultaneous. So who is right? The passenger? The observer? Einstein's letter answers. Both. Each experience is true in its own frame. And from this simple truth, space and time begin to bend. The idea is not loud. It doesn't need to be. It unfolds gently in your mind, like a map redrawn. You sit with it, a universe where clocks tick at different rates, where rulers shrink if you move fast enough, where simultaneity is no longer shared, but local like weather. You can almost feel your surroundings stretch, the room around you still, but your thoughts move now, curling outward like smoke in slow motion. You return to the letter. Its language is careful. Einstein builds his argument like a stone path, each step placed with quiet certainty. He doesn't shout. He doesn't even know if anyone will listen. But the tone says, "Here is something I see. Come see it too." And you do, because this is no mere opinion. It's a reweaving of reality. Thread by thread, his words draw on centuries of questions. Newton's laws, Maxwell's equations, the behavior of light. They've all been puzzling together like mismatched puzzle pieces. And this letter, this unadorned envelope in your hands, clicks them into place. The idea is now called special relativity. But names don't matter here. Not yet. All that matters is the hush of a room, the movement of thought, and the pen that keeps writing. Outside that small apartment, the world moves forward, still caught in the machinery of classical physics, still thinking time is absolute, still thinking mass is fixed, still thinking light is a wave-like sound, rippling through some invisible substance called the ether. But this letter says no. There is no ether. There is no universal now. There is only perspective. And from that, the truth blooms. What was once fixed is now relative, but not chaotic. No, Einstein's cosmos is not disorder. It is deeper order, a harmony you couldn't hear until now. It is the music beneath the silence. You close your eyes and imagine this. Two ships passing in the night sky, their clocks ticking at different rhythms, their measurements of time and distance shifting, not broken, just different. And yet the laws of nature still hold. Always, everywhere. That's the miracle. That's the peace at the heart of the storm. It's as if the universe is whispering, "You are not wrong. You are just in motion." You place the letter down, not because you're done, but because your mind is full, not with noise, but wonder. You wonder how such a letter could be written, how someone could see so clearly through the fog of assumptions, how a young patent clerk, unknown to the world, could reshape it so completely, so quietly. And this is just the beginning. This letter is one note in a larger symphony. Later this same year, he will write again, about light, about energy, about the strange link between mass and motion. But before that, you need to know the mind behind the words. Who was he? What did he see when he closed his eyes? What questions stirred him awake? Tonight, the paper lies still, but thought does not. And so you follow it into the quiet chambers of a restless mind. You step into a small, sunlit room where the dust floats like stars in a private galaxy. There is no noise here, only the hush of thought. The walls are lined not with books, but with questions written invisibly in the air. And at the center of this quiet space stands a young man, thin, thoughtful, almost shy. He stares not at a blackboard or a machine, but out a window into the openness of being. His name is Albert, though he's not yet the one the world will know. Right now, he is simply a man with a restless mind, a mind too vast to sit still in a lecture hall, too gentle to shout, too curious to sleep. He works by day as a clerk in a patent office, reading the ideas of other people, stamping them with approval or denial. But when evening falls, and the street lamps flicker on like stars being lit one by one, his real work begins. It doesn't look like work. There are no experiments, no machines whirring, no lab coats, no assistants. Just paper, and long, long walks, and the kind of thinking that flows deeper than words. Like music with no sound, you follow him through the streets of Bern, where he walks slowly, often with a friend, sometimes alone. Sometimes he speaks out loud, not to anyone, just to the air. He is trying to feel something, not memorize it, not prove it, feel it. He wants to know what it would be like to ride on a beam of light. The thought is so quiet you almost miss it. But once you hear it, you can't unhear it. What if you could travel beside a wave of light? Move with it, keep pace with it, see what it sees. Would the wave look frozen beside you? Would the world around you warp? Would time itself pause? In 1905, no one knows. In fact, no one even dares to ask. You watch as he sits at his desk late at night. His wife and baby asleep in the next room. The lamp casting shadows like slow-moving equations on the wall. He is not a genius in the way people like to imagine. No dramatic outbursts, no sudden revelations. Just patience, and an almost childlike fascination with the simple things. How do clocks work? Why does light behave the way it does? What really happens when two events occur at different times, in different places? These aren't just questions. They are invitations. And Albert accepts each one with quiet courage. He writes to his friends, the Olympia Academy, they call themselves, a group of thinkers who meet in cafes and talk about philosophy, science, music, life. Albert writes in letters, I sometimes feel as though I am a blind man searching in a dark room for a black cat that isn't there. And yet, sometimes I find it. You smile softly at that, because this is not a man trying to impress the world. This is a man who loves questions more than answers, who trusts his mind to go places even maps haven't been drawn yet. He begins to suspect something strange. That time is not the same for everyone. That your clock might tick differently from mine. Not because one is broken, but because motion itself bends the rhythm of time. This is not the kind of idea you can pull from a textbook. It's not something you can prove in a lab. At least not yet. It begins as a feeling. A tension inside reality, like the soft creak of a wooden floor beneath your feet. Something doesn't quite add up, and that's where wonder lives. You see, Albert's gift is not just intelligence, it's imagination. While others repeat what's been taught, he dares to dream differently. And the dreams are precise, structured, and careful, but still, at their heart, dreams. He pictures trains and lightning bolts and clocks on towers. He imagines twins aging at different speeds. He closes his eyes and asks, what if the speed of light is always the same, no matter who is watching? And just like that, the universe begins to tilt. You stand beside him as he sketches out ideas with pencil and ink. Each line not a conclusion, but a question drawn more carefully. His handwriting is neat, quiet, almost fragile, like he knows the ideas are powerful and must be handled gently. No one is watching him. There are no medals, no titles, no applause. Just the soft scratch of pencil on paper, and a mind holding the universe together, without even knowing it. Because this chapter, this Einstein before Einstein, is not about genius. It's about stillness. The kind of stillness that listens so deeply. The secrets of the cosmos feel safe enough to speak. You look around the room again. Nothing has changed. And yet, everything is different. You feel the gravity of thought, not like the pull of planets, but like the quiet pull of meaning. It gathers in the corners, settles in the silence. Like dust in sunlight. It doesn't shout. It simply is. And now, something is beginning. A letter is forming, not yet written, but alive in the space between insight and ink. A letter that will change the shape of understanding itself. But first, Albert must follow the light a little longer. He must sit with time, walk beside space, and ask the next impossible question. If the speed of light never changes, what does that do to time? You lie still, eyes closed, body heavy, sinking softly into your mattress. But your mind? Your mind begins to drift, gently, curiously, into a space where thoughts move faster than sound, faster than time. You are no longer confined to the room. You are floating along something strange and silent, a beam of light. Light. It has always felt familiar. You wake with it. You read by it. You close your eyes against it. But tonight, you don't just observe light. You ride it. Not as a passenger in a spaceship, not tethered by technology or fuel. No, just you, your quiet mind, and the idea of speed so constant, so strange, that even time must bow before it. You move forward at 299,792,458 meters per second. Not more, not less, not ever. That's the speed of light. It's a number that sounds scientific, precise, and it is. But it's also a mystery, a universal law written into the bones of reality. It's not just how fast light moves. It's how fast anything can move. A cosmic speed limit, unbreakable and unwavering, even when nothing else in the universe seems so steady. Close your eyes again, if they opened. Let this number become more than data. Let it become feeling. If you could ride this beam, like Einstein once imagined as a boy, a thought he returned to over and over again, what would you see? What would the world look like? You begin to notice something. Things stretch. Clocks, ticking in a room far below, seem to slow. Rulers in motion appear to shrink. This is not illusion. It is not dream. It is relativity. When you move faster and faster, the universe changes how it appears. Not because the world is strange, but because your motion changes your relationship to time and space. You, moving at the speed of light, don't feel time. Everything around you slows until the seconds freeze. A moment becomes an eternity. A heartbeat becomes 1,000 years. And so, something remarkable happens. You discover that time is not fixed. It bends. It stretches. It flows differently depending on how fast you go. Time is not a ruler measuring the universe. It is a shadow that leans and twists as you move. Now imagine a clock sitting still on a table. It ticks once every second. But if you begin to move faster and faster, that same clock ticks more slowly from your perspective. Not because it's broken, but because you are. Your time slows. This is called time dilation. It's real. It's measured. It's why satellites must account for time shifting in orbit. It's why fast-moving particles live longer than expected. It's why the faster you move, the stranger the world becomes, like a dream where everything floats. But even when everything else stretches and warps, light does not. Its speed remains constant, always. This is the paradox that puzzled scientists for years. If you chase it, it still moves away from you at the same speed. If you move toward it, it still approaches you at that same speed. Like trying to catch a shadow on your wall. It stays the same distance, no matter how fast you run. And this one idea, shattered centuries of certainty. For hundreds of years, people believed in fixed space and absolute time. That clocks ticked the same for everyone, everywhere. That the universe had a steady rhythm. But the light said otherwise. Einstein listened. He imagined riding that beam of light and realized the only way to make sense of its unchanging speed was to accept that time itself had to give way. That space had to curve. That simultaneity, the idea of two things happening at once, was relative, depending on where you were and how fast you were going. Suddenly, physics wasn't about absolutes. It was about relationships between space and time, between speed and perception, between what we thought was real and what actually is. This insight became the foundation of the special theory of relativity, a theory so elegant, so quietly revolutionary, it would be mailed in a letter. No lab, no telescope, just thought written down. As you float on this beam, you begin to understand that science doesn't always need noise or machines. Sometimes it begins in stillness, a stillness of thought, a space where imagination stretches further than any rocket, where questions pulse like stars in the dark. And this one question, what would happen if I rode a beam of light, changed everything. You drift now, gently, through the implications. If time slows when you move fast, then nothing is absolute. Your experience of reality depends on how you move through it. The same events can look different to different observers. Reality becomes layered, personal, shifting, curved. At first, this feels unsettling. But then, like any good mystery, it begins to soothe. It means you're not wrong for seeing things differently. It means the universe is more flexible than you imagined, more forgiving, more alive. Imagine two twins. One stays on Earth. The other travels near the speed of light, then returns. When they reunite, they are no longer the same age. The traveling twin has aged more slowly. Time, in a sense, became thinner for them. A nap that lasted decades. This isn't fiction. It's physics. Even gravity bends time, but that comes later. For now, you float in this liminal place between understanding and wonder, between what is measured and what is felt. You begin to see how even something so simple, a ray of light, carries within it the power to remake our worldview. Einstein once said, "Imagination is more important than knowledge." And as you float here, weightless in mind and body, you understand why. Knowledge catalogs what is. Imagination opens the door to what could be known. And sometimes, it's that quiet voice, it begins with 3 soft symbols resting on a page. Just 3 characters quietly arranged. E equals mc squared. They don't shout. They don't twist or turn. They simply sit, as though they've always belonged together. But beneath their simplicity hums a universe of revelation. Tonight, you sit with them, not to solve them, but to feel their rhythm, to trace the lines between energy and matter, light and mass, silence and motion. Let the day soften around you. Let the edges of your thoughts blur like distant stars in a twilight sky. You are not here to memorize. You are here to remember something you've always somehow known, that everything, at its core, is made of the same gentle fire. E stands for energy. It's in the warmth of your skin, in the beat of your heart. It pulses in the glow of a star and in the charge of lightning. But it also lives in quieter places, in a pebble resting in a stream, in the stillness of your breath, in the cool weight of a stone on your palm. Energy is not always loud. It can be stored, waiting. It can sleep, folded tightly inside matter. And that's where M comes in. M for mass, the tangible, the solid, the stuff of the world. But here's the truth whispered by the equation. Mass is not what we thought it was. Mass is not fixed. It's not a lump or a thing. Mass is potential. It's energy slowed down, curled in on itself, like a dancer pausing between steps. And what connects the two? What turns mass into energy and energy into mass? See superscript 2, the speed of light squared. Light, fast, constant, eternal. It doesn't bend to our clocks or our footsteps. It is the cosmic bridge, the link between the invisible and the visible. So, E equals mc squared becomes a quiet song, a whisper that says, everything contains energy, even you, even the chair you sit on, even a spoon resting in a drawer at midnight. If you could take just 1 gram of mass, a sugar cube, say, and release all the energy within it, it would be enough to power a city for days. Imagine that. A sugar cube glowing like a small sun. But don't worry, you're not going to explode. Nature is wise, and it keeps most of this energy carefully folded deep inside matter, where it rests. Still it's there, sleeping. This equation didn't arrive in a laboratory. It wasn't born of thunder or applause. It was part of a letter, scribbled in quiet thought by a man who saw connections where others saw walls. Einstein, who didn't see math as a tool, but as a language, the soft, sacred grammar of the cosmos. He didn't set out to change the world. He only wanted to understand why it moves the way it does. Why does light behave so strangely? Why does mass resist motion? Why do time and space feel elastic, depending on your speed? And from those wonderings, from long walks, long silences, long looks into the invisible, this equation emerged. He didn't need to shout it. He didn't patent it. He just wrote it down. And quietly, the world began to shift. You might ask, how can energy and matter be the same? Close your eyes and think of water. It can be a solid, an ice cube, a liquid, a stream, a gas, a mist rising from tea. It changes form, but it's still water. Energy and mass are like that, 2 forms of the same thing. They transform, under pressure, under time, under force. A star is born when atoms fuse, releasing energy. A star dies when that energy is spent and mass collapses into silence. Even in our bodies, deep within our cells, energy changes shape constantly, fueling thought, healing skin, warming our breath. You are not separate from this. You are a small, glowing part of the equation. You are a being of matter, yes, but also of energy. Every cell, every pulse, every dream you carry is part of this ancient balance. And what happens when this energy is unwrapped? Sometimes it powers homes. Sometimes it moves machines. Sometimes, tragically, it fuels weapons. The equation itself is neutral. It doesn't tell us what to do. It only tells us what is possible. And that is its quiet strength. It asks us to choose, with care, how we shape the future. Because now, we know what lies beneath the surface. We know the sleeping fire within a grain of sand. We know that the invisible holds power, sometimes more than the visible ever could. And so, in this moment of stillness, as you lie back and feel the softness of the air around you, know this: every object you see, every moment you live, is filled with energy. Some flowing, some waiting, all connected by that simple equation, like beads on a string of light. E equals mc squared. It's not just a formula. It's a bridge between science and imagination, between the known and the mysterious, between the world as it appears and the world as it truly is. A letter once carried this idea, folded into its pages like a seed. And like all seeds, it waited patiently for someone to notice, for someone to wonder. And wonder, you do? You feel the balance. You feel the softness of matter and the warmth hidden within it. You feel the equation echoing inside your body, inside your thoughts, inside the stars. And you wonder, who was this quiet mind who first saw it? Where was he when the symbols came together? How does a simple clerk, not a king, not a general, write a truth that reshapes reality? As you drift further into stillness, the question opens like a door. And through that door, you glimpse a desk, a stack of papers, and a man writing by lamplight, changing everything. In a quiet office with walls the color of faded cream, the hum of ordinary life ticks gently in the background. You are sitting across from a man whose desk is littered with patent files, inventions and machines you've never heard of, drawn in neat lines and dusty ink. The light filtering through the tall windows is soft and pale, casting long shadows over stacks of forgotten ideas. Here in Bern, Switzerland, it is 1905, a year that will one day be called Annus Mirabilis, the miracle year. But right now, nothing feels miraculous. It feels quiet, steady, even boring. He's just a clerk. That's what people say. A third-class technical expert. Not a professor, not yet. Just someone who spends his days sorting through other people's imaginations, checking if their gears and wires make sense. And yet, while others see paper, he sees patterns. While others see diagrams, he sees deeper truths. You watch him adjust his wire-rimmed glasses. He's reviewing a design for a timekeeping mechanism, and something flickers in his gaze, a glimmer of a thought not entirely about the patent in front of him. He pauses. He leans back. A question rises behind his eyes like a tide. What is time? The question doesn't come from ambition or noise. It rises out of stillness, the kind of silence that gives thoughts room to grow. The clerk's name is Albert Einstein, and in the margins of routine, he is quietly rearranging the rules of reality. He has no laboratory, no chalkboard filled with equations, no lectures to give. His tools are simple: scraps of paper, a fountain pen, long walks after work, and a mind that refuses to accept the world exactly as it seems. He does not chase fame. He chases clarity. Sometimes he imagines what it would be like to ride alongside a beam of light. What would he see if he traveled as fast as light itself? Would the wave freeze? Would time stop? Would space stretch like warm wax? This is not idle daydreaming. This is how he works. Through thought experiments, questions turned into visual journeys. He calls them Gedanken experiment, thought as telescope, imagination as microscope. And one day, during these private wanderings of the mind, something clicks. He realizes that if the speed of light is always the same, no matter how fast you're moving, then everything else we take for granted must bend around it. Time slows down, lengths contract, mass increases, not because the universe breaks, but because it flexes quietly, naturally, like breath. He writes these thoughts in the evening hours, after the world has gone to sleep. There is no grand announcement, just quiet scribbling under a dim lamp. He writes 4 papers that year, each one reshaping a cornerstone of physics. But one of them, just a few pages long, contains something almost playful: E equals mc squared. It is in this room, above a sleepy Swiss street, that the letter is born, the one that will ripple outward for generations. You look again at the man across from you. He's not trying to change the world. He's trying to understand it. And in that humble pursuit, done not in glory, but in stillness, he does change the world. His letter is sent not to kings or generals, but to a scientific journal. The paper is accepted, printed, and filed without much noise. For now, no one realizes what just happened. But inside that brief equation, E equals mc squared, is the quiet folding of matter and energy into one seamless truth. It says, mass is energy. A pebble, a spark, a drop of rain, all hold untold fire within. It's as if he reached into the fabric of the universe, tugged gently, and revealed its hidden stitchwork. You close your eyes and feel it. The beauty of simplicity, the elegance of thought that needs no fanfare. You begin to understand that revolutions don't always start with noise. Some begin with a question asked at a desk, during a lunch break, in a room full of paper. Einstein, the clerk, is proof that even the quietest minds can shake the stars. And yet, his idea, though born in peace, will not remain untouched. As it travels through time, the world around it changes. Nations will rise, tensions will grow, and the fire hidden in matter will be tempted. But that part of the story hasn't arrived just yet. For now, you linger in the stillness of discovery, where a thought becomes a letter, and a letter becomes a legacy. And as you rest beside the clerk, you lie still, your breath soft and steady, as if syncing with something far older, far wider. Outside your room, the world slumbers, but inside your mind, something stirs, a question without sharp edges, a mystery without fear. Tonight, you drift not into dreams, but into the fabric of space itself. Close your eyes. Now, imagine the sky as it once was, before humans, before stars, before time knew how to tick. Picture silence, not as the absence of sound, but as a vastness waiting to be filled. You are there, in that stillness, floating beyond beginnings. The universe doesn't explode into existence. It exhales, softly, slowly. This isn't the violent bang we're told about in headlines. This is the whisper of something becoming. A warmth, a flicker, then motion. Not objects moving in space, but space itself stretching, growing, blooming like a flower unfolding in cosmic time. You're not watching from the outside. You're inside it. Inside a breath the universe takes over billions of years. Galaxies, born of stardust and silence, drift apart not because they're pushing, but because space between them is swelling. They ride the currents of expanding space, like leaves carried by the tide. It's hard to imagine space itself growing, but think of rising dough. The raisins inside don't move on their own. The dough between them stretches. Galaxies are the raisins. The universe is the dough. And this idea, this wild, poetic idea, lived quietly in the folds of a letter. A simple equation gave birth to a new way of seeing. That energy and mass are not just interwoven, but that space and time themselves respond to energy's presence. Heavy things bend space. Light things move through that bend. And the universe? The universe doesn't sit still. It listens to mass, to energy, to pressure. It moves accordingly. Einstein's theories didn't just change how we measure things. They changed how we imagine the stage on which all things move. He believed in a static cosmos at first, a quiet, eternal space. But even he would be surprised by what came next. Years later, others followed the threads he left behind. They read his letter. They did the math. And the math spoke back. The universe cannot be still. It must either contract or expand. We now know which path it chose. As you float deeper into this thought, imagine galaxies as dancers. They twirl in silence, but with each step, the floor beneath them stretches. The space between galaxies grows, and the farther one is from another, the faster it appears to move away. This isn't because they're fleeing. It's because the stage itself is expanding beneath their feet. Astronomers, peering through glass and mirrors, noticed something strange in the light of distant stars. The light was redder than it should be, stretched like the lowering hum of a siren passing by. This redshift was a sign, a clue. The universe, they realized, was not only big, it was getting bigger. And you? You are part of it. Your body, made of star remnants, rides this expanding wave. Every second, the space around you stretches, imperceptibly, but endlessly. You are not still. You are carried. If you listen closely, you can almost hear it. Not a sound, but a feeling. The soft pull of space stretching like silk between galaxies. The cosmic hum of a universe in motion. There's something deeply comforting in this. That even in what feels like stillness, everything moves. Nothing is fixed, not even the void. Change is not disruption. It is the heartbeat of reality. The sky you see tonight is a time machine. The light from distant stars left its source millions, even billions, of years ago. You are not looking at where things are, but where they were. Light, the quiet messenger, brings stories from long ago, whispering into your eyes. This is how it used to be. And what of the future? The universe will keep expanding. Galaxies will drift so far that their light may never reach us. The night sky may grow lonelier. But even then, the legacy of that letter, the idea that space can breathe, remains etched in the very fabric of the cosmos. You curl gently into your blanket, realizing that expansion doesn't always mean noise or chaos. Sometimes it means growth. Quiet, unending growth. Like the slow opening of a flower. Like the deepening of thought. Like the widening of a mind. In every direction, there is more than there was before. The universe grows, and you grow with it, thought by thought, breath by breath. And yet, questions remain. If the cosmos is expanding, what is it expanding into? Is there an edge? A beyond? Or is space all there is, with no boundary to push against, only more becoming? These are not questions to answer tonight. What if you could hold a single grain of sand and feel inside it the power of a star? You close your eyes and begin to drift downward, not through space, but through matter itself. Down past the surface of your skin, past cells, molecules, atoms, deeper. The world you know dissolves into something smaller, quieter, and far more powerful. You are now inside the invisible, inside a space so small that 10 million atoms could line up across the width of a single hair. But in here, everything pulses with potential. Atoms seem still, but they are alive with energy. Their cores, the nuclei, are dense little knots of mass, wrapped in tiny storms of invisible force. And as you watch, you begin to feel what Einstein meant when he wrote that simple line. E equals mc squared. Energy equals mass, multiplied by the speed of light twice. It sounds like math, but it's really a whisper. A whisper that says, there is more inside everything than you can see. Mass, the stuff of things, can become energy. And energy, radiant, glowing, electric, can become mass again. This is not just a trick of equations. This is the very language of the universe. And the atoms around you, and within you, speak it fluently. In the center of each atom is the nucleus, and in it lies most of the atom's mass. Protons and neutrons, packed close together. They are held in place by something strange and powerful. The strong nuclear force, nature's glue, invisible but unbreakable. For a long time, people thought the atom was indivisible, a solid ball. But inside it was a secret waiting to be split. In the early 20th century, that secret began to unfold. Scientists discovered that when you split an atom, specifically the atoms of certain heavy elements like uranium, you unleash something astonishing. A tiny fraction of the atom's mass vanishes, and in its place, a burst of pure energy, a ripple, a flame, a fire born from silence. That missing mass becomes light, heat, motion, all governed by Einstein's equation. E equals mc squared. A little mass multiplied by the square of the speed of light. A small number becomes an unimaginable force. 1 gram of mass, fully converted, could power a city for a day. It is not magic. It is balance. Nature trading one form of existence for another. This is the fire that fuels the sun. Look up at the stars, even now, if night surrounds you. Each tiny dot in the sky is a furnace. In the core of every star, hydrogen atoms fuse into helium. They come together, releasing energy as they do. A little mass is lost and turned into light. The same equation, the same law. That golden warmth on your face on a summer day, it began as fusion in the heart of the sun. Mass turned into energy, journeying 93 million miles. To touch your skin, even in darkness, the atoms in your body remember the sun, because they, too, were born from ancient stars. The carbon in your bones, the oxygen in your breath, forged in supernovas long ago, and inside your body, in every living cell, tiny molecular machines hum along, using energy to grow, move, heal. That energy flows from food, from warmth, from sunlight. And deep in that cycle, the same rule quietly applies. Energy, Massachusetts light, all speaking the same cosmic tongue. The letter Einstein wrote so long ago was not just a theory. It was a mirror held up to nature's hidden face. A reminder that even in the smallest particle, the universe is still unfolding. But there's more. Because what the letter revealed was not only power, but responsibility. To understand that mass can become energy is to know how stars shine, but also how bombs explode. A secret that brings both light and shadow. And soon, the world would discover just how deep that truth cuts. But for now, here in this quiet place beneath the surface of things, you rest in the glow of knowledge. You feel the steady hum of atomic fire, not loud, not dangerous, just present, alive, waiting. You are made of matter, and inside matter is energy. And energy, like thought, can transform the world. Tomorrow will come, and with it, the echoes of how this discovery shaped history. In war, in peace, in invention, and in regret. But tonight, you stay here. In the quiet warmth of knowing, ideas begin gently. They sit on the edge of a notebook, sketched in quiet ink. They drift through solitary minds at midnight, where the world is hushed and all that exists is thought. E equals mc squared began this way, as a whisper, a concept, a graceful truth about the balance of mass and energy. You cradle that thought again, its curves still glowing in the dark of your imagination. Energy is mass. Mass is energy. The tiniest grain of matter holds the might of a storm. It was a beautiful equation, born not for war, but for wonder. A soft realization that the world is full of invisible symmetries, and that the universe is more deeply connected than anyone had guessed. But ideas, like seeds, do not choose where they fall. Some land in gardens, others land in fire. Now, you drift gently forward in time, into the 1930s. A world stirring with turbulence, a time when science and politics begin to entangle. Across the ocean, in Europe, unrest grows like cracks in the ice. And far from the ivory towers of thought, a new kind of urgency rises. You find yourself beside a man who has always cherished peace, his hair wild with time, his gaze always searching beyond the visible. Albert Einstein, the same quiet thinker who once imagined riding alongside a beam of light, now paces not with wonder, but with worry. The Nazis have risen. Their power spreads swiftly across borders and hearts. And among their scientists are men with the knowledge and the means to turn theoretical physics into weaponry. Rumors swirl that Germany may build a bomb. Not any bomb, but one powered by the very heart of matter, by splitting atoms and releasing the fire locked inside. Einstein, now living in the United States, feels the tremor in history. He is not working on nuclear fission. In fact, he does not believe he should. But others are, men like Szilard, Fermi, and Teller. And they are afraid enough to act. So they draft a letter. In a small cottage on Long Island, Einstein signs it. August 2nd, 1939. A new letter, very different from the first. Not a poetic vision of mass and energy, but a warning. A plea to President Roosevelt, urging the U.S. to take the possibility of atomic weapons seriously. The message is quiet, but it ripples. Within months, the Manhattan Project is born. A secret effort to race toward a new kind of bomb before Germany can. You drift now through its hidden halls, beneath desert skies and inside chalkboard-covered rooms. Los Alamos, Oak Ridge, Hanford, cities within cities, built not for life, but for calculation and silence. Men and women walk the corridors with badges and numbers, never fully knowing what they are part of. They measure, they refine, they theorize, And all the while, the core truth remains. A tiny bit of mass can become an enormous burst of energy. E equals mc squared, once a thought of beauty, is now a formula behind fission, fueling the most destructive weapon the world has ever imagined. And then, on July 16, 1945, just before dawn, in the New Mexico desert, it becomes real. The first atomic bomb is tested. You float there, unseen, in the hot, quiet air. The moment is still, like breath being held. And then, light. A bloom brighter than the sun. A shock wave that ripples across the ground and through the soul of science itself. Robert Oppenheimer, the physicist who helped lead the project, later recalls a line from an ancient text. Now I am become death, the destroyer of worlds. But the world does not stop. 3 weeks later, bombs fall on Hiroshima and Nagasaki. And suddenly, E equals mc squared is no longer a quiet marvel. It is a ghost, a force, a scar. The equation, pure and neutral, did not ask to be used this way. It offered truth. But humans, with all their fears and ambitions, chose its purpose. You drift through the aftermath. Science is not good or bad. It is a tool, a mirror, a lantern in the dark. And like any light, it can warm or burn. Tonight, as you rest, let your thoughts drift between both truths. That the letter sparked destruction, but it also illuminated the path to insight. In this strange duality, you feel the quiet ache of human progress. How knowledge, when unanchored from compassion, can grow teeth. And how even the most beautiful ideas can be twisted by urgency and fear. Still, even in the shadow, something glows. A question, a soft, unfinished thought. What else has this letter touched? What quiet revolutions has it started? Not in war rooms, but in everyday life? What new worlds has it made possible? In ways we forget to notice? Let's walk into those worlds next. Quietly, gently. There's more this letter has written than we can ever truly read. The room around you softens into silence. The gentle hum of your breath, the rhythm of your heart, it all becomes part of something greater. You are still, but the world beyond you is in quiet motion. And the reason? It all circles back to a thought, once scribbled in a letter. A thought that changed the rhythm of reality. E equals mc squared. Just 5 characters. But behind those strokes of ink is a shift so profound it changed not just science, but the world you live in. The idea was simple, yet it bent the spine of what we thought was true. Energy and mass, 2 things once thought separate, are now forever linked. A whisper of matter holds an ocean of energy. A single gram of mass can become a lightning storm of light and fire. And so, from this quiet equation, a new era dawned. You feel it in the devices that hum in your pocket, the satellites floating like silver fireflies above the earth, the power grids humming softly beneath cities. None of it could exist without that letter, without the idea that energy and matter dance together, not opposites, but twins. You walk slowly, in your imagination, through a world shaped by thought. You pass by hospitals lit by machines that image the body through waves of radiation. You pass towers filled with lasers that carry voices across oceans. You drift over fields where GPS signals, precise to the meter, triangulate your every step. thanks to adjustments for the bending of time, as Einstein once predicted. Even your own sense of time, your clocks, your calendars, echo with his influence. The letter did not remain on a desk, sealed with wax and forgotten in a drawer. It leapt softly into every corner of modern life. It traveled through chalkboards, lecture halls, and laboratories. It passed through books and classrooms and was whispered into the ears of those who would build the next great things. This is how thought becomes reality. Not all at once, not in grand fireworks, but slowly, in layers, like morning light spilling into a quiet room. And it's not just the physical world that changed. It's the way we see the universe and ourselves. Before that idea, people believed space was a stage, unmoving, eternal. Time ticked like a metronome, steady and absolute. But Einstein's insight, first breathed into that quiet letter, said otherwise. Space can curve, time can stretch, and reality is not fixed, but flexible. You don't just exist in the universe, you shape it by your motion through it. The idea opened the door to quantum discoveries, black hole theories, gravitational waves. It gave scientists permission to question everything, to trust thought over tradition, to believe that imagination, when paired with precision, could reach truths deeper than any ruler or clock could measure. Tonight, as you lie still, your body at rest, your thoughts can wander freely, because someone once dared to follow a thought where no one else had. And because of that, the world you now live in, this world of shimmering technology, mapped atoms, and distant galaxies, is a product of that single act. A human mind asking, what if? You are not separate from this story. You are, in fact, a continuation of it. The device you hold, the electricity that powers your home, the gentle hum of data passing invisibly through the air. All these are threads in a vast web of thinking. You use the fruit of that thought every day, and perhaps, without noticing, you carry it forward. Every question you ask, every curious glance at the stars, every time you pause and wonder how something works, you are living inside the echo of that letter. Because thought, once released, never really disappears. It expands, ripples, transforms, just like energy, just like light. So here you are, breathing in a world rewritten by that one idea. A world where time bends, where stars are born from collapsing clouds, where nuclear power is both danger and hope, where the invisible becomes knowable, and where each of us is made not just of matter. Tonight, as your breath softens and your body becomes weightless against the pull of the day, the letter begins to move again. Not through mailboxes or dusty archives, but through memory, through mind, through wonder. The paper may have yellowed, the ink may have faded, but the ideas it carried still ripple like echoes across time. You are no longer holding the letter in your hand. You are walking inside it. It doesn't matter if you understand every equation, every symbol, or even every name. Because this letter, the one that changed the course of science, wasn't just made of knowledge. It was made of curiosity. And curiosity doesn't need credentials. It only needs a question that won't let go. Somewhere, under the slow-rolling sky, a child looks up and wonders why the moon follows them home. Elsewhere, a student stares at a glass of water and thinks, how does light bend through this? In quiet corners of the world, minds are still asking, still reaching, still feeling the tug of something more. That's the journey the letter is on now. Not confined to a single moment in history, not trapped in Einstein's hands or sealed inside museum glass. It floats, like light, from person to person, invisible but alive. It travels through questions asked at midnight, through scribbled notebooks, whispered thoughts, bedtime stories. It becomes part of how we see the world, not just what is, but what could be. The equation, E equals mc squared, is just one small part of the message. Energy and mass, yes, the secret inside stars, the bond between matter and light. But behind the math is a deeper, softer idea, that the universe hides simple truths in plain sight, and that even the smallest mind, in the quietest moment, can uncover something vast. Tonight, as you lie here, your heart beating gently like a clock without hands, you are surrounded by the afterglow of those truths. You are wrapped in a universe made of stories, of things discovered, and things still waiting to be known. And maybe, just maybe, your own thoughts are becoming part of that long conversation. Every scientific discovery, every revolution in thought, begins not with an answer, but with a humble noticing. The way apples fall, the way stars shimmer slightly out of place, the way time feels slower when we're sad, the way your breath moves when you listen, not to noise, but to stillness. Einstein's letter wasn't meant to be grand. It wasn't written to change the world. It was an offering, an attempt to share a thought that had taken root in his mind and refused to leave. And isn't that how most important things begin? With a single moment, a flicker of insight, a whisper in the dark. And now that whisper is in you. You may never solve an equation or write a theory, but every time you wonder, truly, gently wonder, you are taking part in the same journey, the one that sent that letter forward, the one that continues through you. Because science is not just a body of facts, it's a way of seeing. It's the practice of staying curious, even when the answers are slow. It's the courage to ask, even when the question feels too big. Maybe that's what travels now. Not the paper, not the ink, but the question behind it. What if the universe works in a way we've never imagined? And so, the letter finds new hands, new eyes, new dreamers. It hides in classrooms and library corners, in notebooks and lab benches, in star charts and lullabies. It waits patiently inside every curious glance, every thoughtful silence. It doesn't demand attention. It doesn't shout. It arrives, as it always has, quietly, in stillness. You feel it now, not as words, but as warmth. A gentle invitation from the universe to listen, to learn, to lean into wonder. To ask not because you must, but because you can. Even the stars above you tonight, glowing with borrowed fire, are messengers of that same story. Their light, traveling for millions of years, reaches your eyes in this moment. Proof that some messages never stop moving. Just like the letter, just like the idea, just like you. And as you drift further into rest,